So I'm going to solve the mathematics section now. So we'll see. So here you have the first question. If all the equations x squared plus 2a plus 3b the whole into x plus 60 is equal to 0, and x squared plus ax plus 10 is equal to 0, and x squared plus bx plus 8 is equal to 0, where a and b are real numbers, have a common root, then what is the value of the modulus of a minus b? Okay, to solve this question, so we know that they have a common root, right? So we let the common root be alpha. So because some number that we know, right? So now we substitute the alpha into all three equations. So now we realize that alpha squared plus 2a plus 3b into alpha plus 60 is 0. And at the same time, alpha squared plus a alpha plus 10 is also equal to 0. And alpha squared plus b alpha plus 8 is also 0. Now, we want to first find alpha. So alpha is equal to what, right? So to find alpha, we want to eliminate what we don't know, which is a and b, which are the constants that we do not know. So what we do is we multiply the second equation by 2, so that we'll get 2 alpha squared plus 2a alpha plus 20 is equal to 0. And we multiply the third equation by 3. So we will get 3 alpha squared plus 3b alpha plus 24 is equal to 0. Then we add both those equations. So we will get 5 alpha squared plus 2a plus 3b times alpha plus 44 is equal to 0. So now we see that, so in this equation, since we have a 2a plus 3b, we know that we can always cancel. We can cancel the 2a plus 3b term by subtracting equation 1 and this new equation 4, let's say, that we have generated. So, okay, so how do we do that? So if we subtract, we'll get 4 alpha squared plus 44 minus 60 is equal to 0, which means alpha squared is equal to 3. So alpha is equal to plus or minus square root of 3. Okay, how will this help us? So firstly, let us assume that alpha is one of plus or minus square root of 3. Okay, let's say first we assume it is plus square root of 3. If you assume it's square root of 3, we can substitute that into both the equations. So we'll get 3 plus root 3a plus 10 is equal to 0, which means a is equal to minus 13 by square root of 3. If we substitute in b in the second equation, we will get 3 plus square root of 3b plus 8 is 0, which means b is equal to minus 11 by square root of 3. Let us see if this is consistent with what we observe. Okay. Oh wait, sorry, 1 second. I have made a mistake. The mistake I made is 4 alpha squared plus 44 minus 60 is 0, which means 4 alpha squared is equal to 16, which means alpha squared equals to 4, which means alpha is not root 3, it's plus or minus 2. So I'll erase that part. So alpha is 2. Okay. So which means we substitute 2, we'll get 4 plus 2 alpha, 4 plus 2a plus 10 is 0, which means a is equal to minus 7. Then if we substitute 2 into the second equation, we'll get 4 plus 2b plus 8 is 0, which means b is equal to minus 6, which means a and b differ by 1. So therefore the answer is 1. Okay, now we have the second question. A squared plus a plus 2 the whole times x squared plus minus a plus 4 times x minus 7 is some function f of x. 1 lies between the roots of f of x. So how do we approach this kind of question? So first what we do is, I'll erase these things. First we draw the function, okay? So an important thing to do is, at any point, if you find this kind of question where we are asked a type where we want to find out where roots are. So what we do in that situation is that we first draw the graph of the function. So we know that this is a parabolic function. So this is either an upward parabola or a downward parabola, depending upon the sign of a squared plus a plus 2. So however, However, this is a, let us just assume, let us just go with one assumption. Okay, to first draw. Let us say that it is positive. Okay, so the parabola is going to look something like this. One is clearly a root and it lies between both the roots. So since both the roots are there, the discriminant is greater than 0. So that is one thing that we observe. So discriminant greater than 0, and not only that, 1 also lies in between both the roots, which means f of 1, as you can clearly see, is negative in this case. But you know that if the parabola was a downward parabola, f of 1 would be positive in that case, which means what essentially the condition is that the sine of f of 1 multiplied by the coefficient of x squared should be a negative quantity. So in other words, a squared plus a plus 2 the whole times f of 1. F of 1 is, if you just substitute 1, you see that a squared plus a plus 2 minus a minus 4 minus 7. So a cancels. 2 minus 4 is minus 2 minus 7 is minus 9. A squared minus 9 is basically f of 1. So that is negative. We know that a squared plus a plus 2 is always positive because that's always a positive quantity, which means a squared minus 9 is less than 0, which means a is always between minus 3 to 3, excluding both of them, which means a can only take the values of minus 2, minus 1, 0, 1, and 2, because we're talking about integral values here. Now, another important condition here is that the discriminant should be greater than 0. So let us test that out. So b squared minus 4ac is the discriminant, right? So a squared plus 8a plus 16 minus 4 times a squared plus a plus 2 times minus 7 is greater than 0. So a squared plus 8a plus 16 plus 28 times a squared plus a plus 2. So if you observe the discriminant, you can see that clearly both the terms and discriminant are always greater than 0. So this is nothing to worry about. This is something that's always greater than 0. So finally, that's it. So we have checked for if discriminant is greater than 0, which means the function parabola contains two roots, two distinct roots, and we know that that is always the case. Now, secondly, we also have written a condition for which one always lies between the roots of the function, with which we have gotten 5 values: minus 2, minus 1, 0, 1, and 2. So answer is 5. Number of integers in a range of a for which roots of x squared minus 2x minus a squared plus 1 is 0 lies in between the roots of the second equation. So again, in this kind of question, we'll again draw a graph. Okay, clearly in this case, both the parabolas are upward facing because the coefficient of x squared in both them is plus 1. So which means we don't need to worry about which way it's facing. So this is one parabola, let's say. Okay, since we already have, I'll just erase this one part. Yes. So we know that the other parabola has to look something like this, because by definition, the question asks us to find the number of integers array for which the roots of the first parabola should lie between the roots of the second parabola. Right. So, okay. So what does that mean? So let us say, which means, let us say we have a root. So let's first carefully observe the second equation. Okay. If you observe the second equation, you find that it is x squared minus 2x plus, okay, minus 2ax plus a squared minus a is equal to 0, right? The second equation is x squared minus 2x minus a squared plus 1 is 0. So these are the two equations. Now, clearly, since both the roots of the first equation lie in between the roots of the second equation, if let us see if let us first solve for the roots of the first equation. Okay, let us just to get an idea of where the roots are. Okay, so the roots will be minus b 2 plus or minus square root of 4 minus 4 times minus a squared plus 1 divided by 2 into 1. So if you simplify that expression, 4 minus 4 into 1 minus 6 squared. So you get square root of 4a squared, which is 2 times modulus of a. So the roots are clearly 1 plus or minus modulus away. So the roots, so which means this is going to be 1 minus, so this is 1 minus mod A. Okay. And sorry for bad handwriting. Other one is going to be 1 plus modulus away. Okay. So, and now we know, and now we'll try to find out the roots of the second equation. Okay. So second equation is 2 into A plus 1 plus or minus square root of 4 into A plus 1 the whole squared minus 4 into A minus 1. Okay. By 2. So the 2 cancels. A plus 1 the whole square minus, so that's 2A plus 1, 2A plus 1 minus plus A. So A plus 1 plus or minus square root of 3A plus 1. Now we already know one thing. A plus 1 plus square root of 3A plus 1 always is greater than 1 plus mod A. Right? So that's always greater than 1 root. So now the only condition we need is a second root, which is 1 plus A minus square root of 3A plus 1 should be less than 1 minus A. So if you apply that condition, you get 2A less than square root of 3A plus 1, 4A squared less minus 3A minus 1 is less than 0. So you have to find out the number of integers here, right? So number of integers will be, so A is 0 will work. A is 1, 1 also will work. A is 2 will not work, and neither will any value above that. Minus 1 will definitely not work. So you only have 2 values there, right? So for only 2 values. So let us first, let's just verify. Okay, let's verify. If A is 0, both the roots are 1. And here you have 1 plus or minus square root of 1, which makes sense. So that works. If A is 1, then you have 0 and 2 as the roots. And here you have 2 plus or minus square root of 4, which is 2, which is 4 and 0, which also works. So which means the answer is 2. Okay. The range of A for which the equation x squared plus ax plus minus 4 has a smaller root in the interval of minus 1 to 2. So first again we draw the diagram. So let's say minus 1 to 2 is that range. Okay. X squared plus ax minus 4 is a positive parabola. So either the parabola goes like this, or since the smaller root lies inside, this is the only possible case, right? So the smaller root is here, lies between minus 1 and 2, which means f of minus 1 should be positive and f of 2 should be negative, as you can see. So f of minus 1, well, if substitute f of minus 1, we'll get 1 minus a minus 4, which is greater than 0. So if you simplify that, a is less than minus 3 is the condition that we get. Second condition, f of 2 is less than 0. F of 2 is 4 plus 2a minus 4 is less than 0, which means a is less than 0. So from both the conditions, we are clearly getting that a is less than minus 3. However, this is where you have to be careful, because clearly the fact that they're saying the smaller root lies inside some interval means that there is another real root, because if the other root was complex, then this has to be another complex root, because since the coefficients are all real, right, the roots will be in complex conjugates if one is complex. So the other one also is real, which means that there are 2 real roots, which means discriminant should be greater than 0. So if you apply that condition, we'll get a squared plus 16 is greater than 0, which is always true. So therefore the answer is A. Okay. Next, graph of the quadratic polynomial does not pass through what? Okay, well, let's see. So what quadrant? So first, if you put x is equal to 0, we will get minus AB. Minus AB is clearly a negative number, which means that if you draw a graph here, so if you draw a plus here, if you put x is equal to 0, we'll get a into minus b, which is minus ab, which is a negative number. So that point is going to be somewhere here. And you know that's a downward facing parabola, which means the parabola is going to go like this, at least like this. So you should cover at least the third and the fourth quadrants. Now we will see whether it covers either the first or the second quadrants. Okay. So now we know that x is equal to b is a root. X is equal to a is also a root, which means both the roots are positive. So roots will be something like that, right? Which means if the roots are like that and it's negative here, the only possible way for it to pass through is to go like sorry, I'm unable to draw properly. But you can see that it should go through the first quadrant, right? Which means it does not pass through the second quadrant. Okay, this should be a next area question. Okay, you just draw the curve. So if you draw the parabola, the tangents drawn to it from the origin is A. So what tangent will I draw to the origin, right? So so let us say that the tangents meet the curve at the point t comma t squared plus 1. Okay, the derivative of that curve, the slope. So what will be the equation of the tangent at that point? So clearly the derivative is 2x, right? So 2t is the slope. So the equation of the tangent will be y is equal to 2t into x, since it passes through the origin. But this should satisfy t comma t squared plus 1 because that is the point with which it passes through. So t squared plus 1 is equal to 2t into t, which means t squared is equal to 1. So t is equal to plus or minus 1, which means that the points on the curve with which the tangents from the origin meet will be 1, 2 and minus 1, 2. So all we need to find is now the area bounded by the curve and the tangents, right? Is A. Of course, we need to find 27 by 8A. That's an important thing. So we can do this by first integrating the area from minus 1 to 1 under the curve and subtracting off the area of the triangles formed by the tangents. So first, if we integrate, since it's an even function, we can just say it's twice the integral from 0 to 1 of x squared plus 1 dx, which is 2 times 1 by 3 plus 1. X squared integral is x cubed by 3, so you get 1 by 3 plus 1. 4 by 3 into 2 is 8 by 3. So 8 by 3 is the area under the curve. Now what is the area under the two triangles? The two triangles is 2 times half into base, which is 1, into height, which is 2. So the total area is 2. So 8 by 3 minus 2 is the answer, is A essentially. So that is, what is 8 by 3 minus 2? It's 2 by 3. 2 by 3 is the answer, but we require 27 by 8 times 2 by 3. So yeah, so so essentially we'll get 9 by 4, which is 2.25. Okay, next, if y is equal to f of x satisfies the condition f of x equal to f of 4 minus x between 0 and 4, and f of x is equal to f of 14 minus x, where f of x is given to be some piecewise defined function, then what is the area bounded between x0 and 10 and the x-axis? Okay. So first we draw the graph. Okay. First, the greatest integer function of x squared minus 2x plus 5. First, whenever we see something like this, quadratic greatest integer function, we always whole square it. I mean, we'll complete a square. So this is x minus 1 the whole square plus 4. This is easier for us to analyze cases. Now between 0 and 1, we know that x minus 1 the whole square is always between 0 and 1, right? And since x never becomes 0, right? X minus 1 never becomes 1, which means x minus 1 the whole square always lies between the closed interval, between 0 and 1, where 0 is closed and 1 is open. Which means if you add plus 4 to it, it is always closed between 4 and open to 5, which means the greatest integer is simply 4. So without bothering too much, we can say that the greatest integer function is 4 between 0 and 1. Which means since f of x is f of 4 minus x, between 3 and 4 also it is the same case. So 0 and 1, 2, 3, 4. So between 3 and 4 also again it is 4. Okay. Next, 3 plus square root of 2x minus x squared. So this is clearly a function, and so if you put x equal to 1, okay, you get 4. So it satisfies, it's continuous, it's a continuous function. If you put x equal to 2, you will get 3. So it's basically a kind of downward parabola. Okay, and since it's symmetric, you can draw the other side as well. Now, the more important thing to see here is 4 to 7. 4 to 7, it's 20 minus 2x by 3. If you put 4, you'll get 12 by 3, which is 4. So it is continuous. And at 7, it is 20 minus 14 by 3, which is 6 by 3, which is 2. So it dips until 2 as a linear thing at 7. Yeah, but you know that again, 7 to 10, again, it's going to, sorry. Yes. Since f is equal to f of 14 minus x, we must remember that whatever happens from 0 to 7 always also happens from 7 to 14 mirrored. So we know that the same thing happens from 7 to 14. So we can just reconstruct. But we are only interested until 10. So 10 incidentally stops at the mirror image of 4 to 7. So if we integrate, you'll get 4 into 1 plus, what is the integral from 1 to 2 of that expression? Well, integral 1 to 2, 3 plus square root of 2x minus x squared. If we complete the square, we'll actually get 1 minus x the whole square. 1 minus x the whole square dx. And of course, remember that this is multiplied by 2 because we are essentially doubling the area. And similarly, plus another 4 because that's the greatest integer function, plus 2 times integral of 20 minus 2x the whole by 3 from 4 to 7. So this is the total area that we want. So this is essentially 4 plus 4, 8, 8 plus 6, 14 plus 2 times integral 1 to 2 square root of 1 minus x the whole square dx. Luckily, there's a simpler way to solve this integral. Essentially, replace 1 minus x. Basically, reduce. So let's say the integral is from 0 to 1. Okay. So you can shift this entire graph to 0 to 1 and add 1 there, which means you get 1 minus x squared dx. Okay. And this integral is very well known, right? It is simply the area of the circle. It's simply the area of a semicircle. An integral of 1 minus x squared from 0 to 1 is the area of the quarter circle essentially. But the area of a quarter circle is 5 by 4, right? So that's simple. So that is pi by 2 overall. Okay. Pi by 2 plus something else. Okay, now here's where we observe the options. I mean, all of them contain pi by 2, which means we are on the right track. So if we get 40 by 3 into 3 minus 4 by 3 into x squared by 2. So 7 squared minus 4 squared the whole by 2. That's 2 by 3. 7 squared minus 4 squared is 11 into 3. 3 gets cancelled, 22. 40 minus 22 happens to be 18. Okay. 18 plus 14 happens to be 32. So the answer is C. Okay. The area bounded by the curve y squared equals 1 minus x. And the lines y equals mod x by x. Essentially, y is plus or minus 1. Y is equal to mod x by x is actually signum of x. So when x is positive, it's positive. Otherwise, it's negative. So if you draw the curve, right, y squared equals 1 minus x is a parabola. It's a horizontal parabola. To, leaning towards the negative x-axis, and also it reaches y equals 0 when x is equal to 1. So okay, then y is equal to, so when x is equal to 0, y squared equals plus or minus 1. So you observe that as well. So you can draw the diagram appropriately. Okay, so yeah, this is an area question. Okay, it should be a slightly long question, so I'll solve this later. It's the same concept as the previous question. Basically, you draw the diagram properly, you set the bounds for the integration, and you integrate. Okay, is the area bounded by y equals x, y is equal to sin x, and x is equal to pi by 2 is something. So what is the, essentially we need to find the area between x sin x and pi by 2. So if you simply draw the graph, we see that sin pi by 2 is 1, right? So that is where sin reaches its maximum. So we can also draw x, of course, and if x of course at pi by 2 reaches pi by 2. And so we can see that the area between both of them will look something like that, right? So we need to find this area, and this area is simple. We essentially subtract. So the integral is simply integral 0 to pi by 2. That is the bounds, x bounds, and the y thing is simply x minus sin x dx, because you're finding the area between x, y is equal to x and y is equal to sin x. So this integral is not very hard. So this integral is simply pi squared by 4. Sorry, pi squared by 4 y by 2. So that's essentially pi squared by 8 minus integral sin x from 0 to y by 2 simply 1. So answer is 8. See, that's a pitfall there almost. Okay, we have another area question. Again, y is between 0 and x squared plus 1. So that's a region. Then you have y is between 0 and x plus 1. That is also, that's a line. That's another region. And you know that both the curves intersect at 0, 1, and x is between 0 and 2. So when x is 2, we analyze both the curves. So when x is 2, x squared plus 1 is 5. When x is 2, x plus 1 is 3. So we want to find the area under that curve. But you know that x plus 1 and x squared plus 1 intersect at x is equal to 1, right? So essentially the integral is 0 to 1. We integrate 0 to 1, we integrate under the parabola, because the parabola is a tighter constraint, right? Because y has to be less than both the parabola and the line. But parabola is a tighter constraint from 0 to 1, and from 1 to 2, the tighter constraint is a line. So 0 to 1, x squared plus 1 dx, plus 1 to 2, x plus 1 dx. So this is not a very hard integral. Essentially it's 1 by 3 plus 1 plus 1 plus 3 by 2 plus 1. Okay, if you integrate, you'll get that, which is essentially 2 plus 3 by 2 is 7 by 2. 7 by 2 plus 1 by 3, which is 21, 23, 23 by 6. So m by n is 23 by 6. So the lowest value is 29. Okay, f of x is something. This is a very interesting question. So let us just analyze f of x, okay, and you'll get a very interesting answer. So you'll actually get x by 1 plus x power n the whole power 1 by n divided by 1 plus x by 1 plus x power n the whole power 1 by n the whole power n that the whole power 1 by n. So that is a simple. So that expression, if you simplify, right, you'll get x divided by 1 plus 2x power n the whole power 1 by n. Okay, so which means g of x essentially is equal to x divided by 1 plus n x power n the whole power 1 by n. Okay, and we have to integrate g of x times x power n minus 2 dx. So if we integrate that, I of n comma x is equal to, in the indefinite integral, x power n minus 1 by 1 plus n x power n the whole power 1 by n dx. So that is a simple enough integral. Just assume nx power n is dx, right? We get 1 by n squared 1 plus nx. So the result of the integral will be 1 plus nx power n power 1 minus 1 by n divided by 1 minus 1 by n times n squared plus c. Okay. Okay, to clarify. Okay, so okay, yeah. Well, so to clarify, it is going to be to simplify, essentially it is going to be 1 plus nx power n the whole power n minus 1 the whole by n divided by n into n minus 1. Okay, and since we are given x is 1, and we have to evaluate it at x is 1 and n is equal to 10. So substituting both of them, 1 plus 10 the whole power 10 minus 1 by 10, which is 9 by 10, divided by n into n minus 1, n into 9, 90. So 11 power 9 by 10 divided by 90 is our answer. So what is So m by k. So m is 9, k is 10, p is 11, and q is 90. So if we simplify this, now it's just basically substituting. 10k is 100 minus m is 9 minus q is 90 plus p is 11. 100 minus 90 happens to be 10. 10 minus 9 happens to be 1. 11 plus 1 happens to be 12. Okay, next we have another integral. This is not a very hard question. Okay, so if you look at the denominator carefully, you can complete the square. That gives a significant advantage. So it is 3x plus 1 the whole square. If you think about it, the denominator, right? 3x plus the whole square gives you 9x squared plus 6x plus 1. So the actual expression within the thing is 4 minus 3x plus 1 the whole square, right? Now, so that's fine. So completing the square is fine, but you have to split the integral cleverly. So you have to split the integral cleverly. So we'll come back to this little later. Oh, okay. This question is again pretty simple. It's a very straightforward property. If you want to integrate e power x times f of x plus f dash of x, the integral is e power f of x. The way you do this is using product rule. Except here you have e power minus x. So there's a slight modification of that property. E power x times any function. Let us say something times f of x plus f dash of x times f of x times the derivative of that constant. So here in this case, the constant is -1, right? The coefficient, I mean. So you have e power minus x times secant x minus secant x tan x. You know that the derivative of secant x is secant x tan x, right? So that is not much to worry about, and you have a negative sign as well. So integral e power minus x secant x dx is simply minus e power minus x secant x plus integral e power minus x secant x tan x dx. So the answer is simply going to be t. Okay, so we are given another basic integral. So you can approach this with multiple ways, but so one way to use is the beta function. Okay, you first simplify cos power 4x in terms of multiple angles like cos 4x, cos 2x, etc. And then you can evaluate that integral by using the beta function. But let us see if there's a different way to do it. Okay, we can split sin x as sin 6x as sin 4x plus 2x. Why would we do this? Because you have the cos power 4x on the other side. And you know that cos 1 plus cos squared x by 2. 2 cos squared x minus 1 by is equal to cos 2x. So you can build cos 2x using the square of cos. And you can build similarly a cos 4x with a fourth power of cos. Since you have a fourth power of cos, we can build cos 4x and cos 2x, right? So sin 6x is kind of odd, and we'd like to eliminate that by splitting it into 4x plus 2x. So let's do that. Okay. So we know that cos squared x is simply 1 plus cos 2x by 2. 1 plus cos 2x by 2. And so the square of that is going to be 1 plus cos squared 2x plus 2 cos 2x by 4. And cos squared 2x itself is 1 plus cos 4x by 2. And sin 4x plus 2x is sin 4x sin cos 2x plus cos 4x sin 2x. So, well, the first part of the integral, okay, let's just proceed. Okay, actually, we'll get a lot of sines and cosines. So this may not be the best idea. So we'll come back to this question a little later. Okay. This is a very easy question because the derivative of what's inside the square root is really just what's outside the square root times a constant. So we can just, if you let 3 plus 5 x power 4 equals t, then dt is simply 20 x cubed dx, right? So this is simply 1 by 20 integral root t dt, right? And so that's simply root t dt is simply 2 by 3 t power 3 by 2. So if you use 2 by 3, you get 1 by 30. 1 by 30 times 3 plus 5x power 4, the whole power 3 by 2. So clearly it is A. This is also a good question. You know that 1 plus omega plus, so if you simplify the first part, right, you get 1 plus omega squared plus omega cubed. And you know that that's simply 1. So you get 2 plus 3 times 2 plus 2, sorry, 4 plus 2 omega plus 2 omega squared plus omega cubed. What is that? Well, that is 3, because 2 into 2 gives you 4. But you know that 2 of them will cancel out with that. 1 plus omega squared is 0. And you have an omega cubed remaining, so that gives you 1 more, so that's 3. Plus 4 times 3 plus omega times 3 plus omega squared will be the answer, right? So the way to do this is 4 times 3 times 3 will be 9. 9 plus 3 omega plus 3 omega squared plus omega cubed, right? So, but you want 3 to disappear, so it's going to be 6 plus 1, 7. So the series is going to build up like 2 plus 3 into, right, 3 plus 4 into 7 plus dot. What is general term? Well, a general term is n plus 1 times n squared minus n, because n squared is a product, but n will disappear because of the omega and omega squared, plus 1. So this is really the series we want to add, n plus 1 times n squared minus n plus 1, right? So we want to add this series. So let's just make sure that we have the correct answer, because first term is 2. So if you put n is 1, you get 2. Yes. So you want to add this from n is 1 to n is 19. So we just need to generally sum it up. That's not very hard to do. This is just a bit of calculation right now. So this is just 1 to 19. If you look at the first term, if you bring out n squared minus n, that is simply n into n squared minus 1, right? Plus n plus 1. So which is n cubed minus n cubed minus n plus 1, which is n cubed plus 1. Oh yeah. So basically we are summing n cubed plus 1 from 1 to 19. So clearly the answer is n into n plus 1 by 2 the whole square, right? So 19 into 20 by 2 the whole square plus 19 is the answer. 19, so 190. So what is 19 squared? Here's where we do a bit of calculation. So 19 squared is 361, which makes sense, right? 361. So it's 361 into 100. So 36100 plus 19. So it's 36119. Okay. What is the least positive integral value for of x for which x squared minus 4x greater than cot x? So we know cot is a decreasing function. So if we take cos and cot on both sides, we'll get the sign gets inverted, right? But let's see there's a better way to do this. So we know that if cot cot inverse of infinity is 0, cot inverse of minus infinity is pi, right? Cot inverse of 0 is pi by 2, right? And so these are some general things we know. So let's just see how if we draw cot inverse of x, right? We draw cot inverse of x at plus infinity, it's going to be cot inverse of infinity is going to be 0, right? So we know how cot looks as a graph, right? Looks like a decreasing, looks like that, right? With this at pi by 2. Now we know that x squared minus 4x is a parabola, which is 0 here, which has a root of at 4 here, and is like x squared minus 4x is increasing, right? So the least positive integral value is clearly above 4, right? Because between 0 and between 0 and 4, x squared minus 4x is negative, whereas you know that cot inverse is always positive, right? So it's clearly above 4. let's see 5. If you say 5, right? 25 minus 20, so that's 5. Is 5 greater than cot inverse of 5? Right? This is a good question to analyze. And well, so an equivalent question to ask is cot 5 less than 5? Right? Well, 5 radians is an extremely huge quantity, right? And you can see that cot really tapers off, which means this is an agreeable value. Total number of points of intersection are the curves sine inverse of 2x minus 2x by 1 plus x squared and mod of y equals plus or minus 4. So y is equal to plus or minus 4, right? Plus or minus 5 by 4. So sine of 5 by 4 is plus or minus square root of 2, which means essentially we want the solutions of 2x by 1 plus x squared is equal to plus or minus 1 by root 2, which means x squared plus 1 is equal to plus or minus 2 root 2x. That's what we want. And which means x squared plus or minus 2 root 2x plus 1 is equal to 0. So how many points of intersection do we have? Because the number of solutions of the first equation, discriminant is clearly greater than 0, right? 8 minus 4. So okay, let's say it's plus, okay? So it's going to be 2 root 2, so let's say it's minus 2 root 2 plus or minus square root of 8 minus 4 by 2, which means that is root 2 plus or minus 1, right? Otherwise, it's going to be minus root 2 plus or minus 1, which means that there are actually 4 values. Yeah, so actually an interesting thing to worry about here is that we have to worry about extraneous solutions. So no, not really, because the way we have solved the equation itself, we assume that 2x by 1 plus x squared is plus or minus 1 by root 2. So there's no problem here. If cot inverse of n by pi greater than pi by 6, what is the minimum value of n? So clearly n by pi is less than cot of pi by 6. Cot of pi by 6 is cos pi by 6 by sine pi by 6, which is square root of 3. Right? So n is less than pi into root 3. So what is pi? 3.1415 approx into root 3 is 1.732, right? So if you multiply both of them, you will get around 5.2 something of that ballpark. N is less than 5.2, right? So the maximum value of n is n is 5. So the minimum value of n is 0.2. Okay, the number of values for which cos inverse of something plus cot inverse of something is minus pi by 2. Very nice simple answer to this question is 0, because the you know that the range of cos inverse is 0 to pi. The range of cot inverse is also 0 to pi, which means the minimum value of cos inverse plus cot inverse is 0. Whereas we are asked how many values of x for which does it equal minus pi by 2. So the answer is 0. This is actually a very interesting question. If you think about it, sine inverse of x can only accept values from minus 1 to 1, right? Because that's the domain of sine inverse. And you know that the square root makes sure it ensures that it's positive. So essentially, we are only worried about the values between 0 and 1. But you know that the expression x squared plus x plus 1 is always greater than or equal to 1. And in fact, it is only equal to 1 for x is equal to 0 and x is equal to minus 1. So 0 and minus 1 are the only possible values for which 0 and minus 1. Okay, so let's test out 0. If we test out 0, then we'll get tan inverse of 0, which is 0. Sine inverse of 1, which is pi by 2. That works. Let's test out minus 1. Again, works. So 0 and minus 1 definitely work. Does 1 work? No, definitely not. Sine inverse of root 3 doesn't exist. 2 definitely doesn't work either. So it's minus 1 and 0. Okay, the range of this function. X squared divided by 1 plus x squared. The range of that function is between 0, closed 0, because when x is 0, it is 0, to 1, 1 open, because it can never equal 1. It only tends to 1 as x approaches plus or minus infinity. So sine inverse of that clearly takes the values of 0 to pi by 2, but pi by 2 being open, because it can never equals pi by 2. Okay, y is equal to mx plus lambda I. So there are many parallel lines such that the sum of the constants, sum of the c's is 1. A variable line intersects through the origin. Okay, so let's draw. Okay, so there are lots of parallel lines like, and there are lots of parallel lines like that, right? There is one line which intersects all the lines at pi. So at pi, right? Q is a point in the variable line such that sigma of OPI equals OQ. If the locus of Q is a straight line which passes through fixed point A comma B, what is the value of A plus B? Okay, it's a very good question. So Q is a point in a variable line. So a variable line through the origin intersects all these lines, mx plus lambda I, at some at some pi, right? So p1, p2, p3. Q is a point on this line such that OPI is OQ. Okay. So okay. So how do we approach this question, right? So first we have y is equal to mx plus lambda I, right? Let us say the variable line that we are passing, let's say the variable line that we are that's passing through the origin has a form y is equal to nx. Okay. So where do these intersect? Nx is equal to mx plus lambda I. So x is equal to lambda I by n minus m, right? And clearly OP, since it lies along the variable line, it is just simply that the x times square root of 1 plus n squared. 1 plus n squared, right? So now okay. So which means now if we therefore sum all the OPI, we clearly the square root of 1 plus n squared by n minus m is a constant. So we get sum of lambda I, but that is given to be 1. So this so OQ therefore is always equal to square root of 1 plus n squared by n minus m, where n is the variable slope. So okay, what does this tell us? So the locus of Q is a straight line. So which means Q. So basically, so how do we build a straight line, right? So which means, if Q is at an angle of theta, right? If Q is at an angle of theta, where n is equal to tan theta, then its distance must be square root of 1 plus n squared by n minus m. That's what this is saying, right? So, however, we know that if n is tan theta, we want to find it in terms of Cartesian, right? So in Cartesian, cos theta, OQ cos theta will be 1 by n minus m. So its general point will be 1 by n minus m, comma n by n minus m. That will be the general point of the thing, right? So what is the locus of this thing? So the locus will be, so x is equal to 1 by n minus m. So n minus m is equal to 1 by x, right? Similarly, n minus m by n is 1 by y. 1 minus m by n is 1 by y. We want to eliminate n because n is a variable, right? So n is equal to m plus 1 by x. So 1 minus m by m plus 1 by x is equal to 1 by y. So m plus 1 by x minus m is equal to 1 by y into m plus 1 by x. Okay, which means y by x is equal to m plus 1 by x, which means y is equal to mx plus 1, which means it always passes through the point 0, 1. So answer is 1. Okay. If 3a plus 2b plus 6c is a family of straight lines, ax plus by plus c is 0, pass through a fixed point whose coordinates are given by what? Well, we clearly by observation, if we divide by 6, right? 3a by 6, which is a by 2, plus 2b by 6 is b by 3 plus c is 0. So x is half and 1 by 3 satisfies this. A line L passes through 1, 1 and 2, 0. So by this, you can ascertain its slope to be -1, right? And an L dash passes through half, 0 and perpendicular to L. So its slope has to be 1. So what is the area of the triangle formed between the y-axis L and L dash? Okay, so since the slope is 1, right? We know that the slope of the L dash is going to be the equation of L dash is going to be y is equal to x minus half, right? Which means it intersects the y-axis at minus half, 0, right? Now, now where does L intersect y-axis? Well, 0, 2, right? Where does L and L dash intersect? Well, that's a good question. So x plus y is equal to 2 is the other line. So if you just solve, right, 2x minus half is equal to 2. 2x is equal to 2.5. 2x is equal to 5 by 2. X is equal to 5 by 4. So they meet at 5 by 4, 3 by 4. Okay. So therefore, therefore the area is simply going to be half into base, which is 2.5, right? 5 by 2 into height, which is 5 by 4. So that's 25 by 16. Suppose the family of lines is orthogonal. Suppose the family of lines be normal to a family of circles. What is the radius of the circle of the family which intersects a circle orthogonally? Okay, so clearly, if you look at the circle, its center is 2, 2, and its radius is 3. Its radius is 3, right? So the family of lines is normal to the family of circles. If it's normal to family of circles, clearly the center of the family of lines corresponds to the center of the family of circles. The radius of the circle of the family which intersects the circle orthogonally is what? So A, B, and C are an arithmetic progression, right? So one thing you can say is 2B is equal to A plus C, which means A minus 2B plus C is 0, which means this family always passes through 1, -2. It's a fixed point. 1, -2 is a fixed point through which this family passes through, which means 1, -2 is also the center of the family of circles, as we just discussed, right? Which means since now, so now we know that the radius of the given circle is 3, center of the given circle is 2, 2. We know the center of the family must be 1, -2. For orthogonality, we know that the square of the radii must be the square of the distance between the centers. Square of the distance between the centers in this case is simply 1 squared plus 4 squared, which is 17, which is equal to 9, which is equal to square of the first radius, which is 9 plus r squared. So r squared is simply 8, which means r is equal to square root of 2 root 2. 2a plus 2b plus c is 0. L1 and L2 are straight lines of family something, which are at unit distance from the point 1, 1. Then what is the area bounded by L1, L2 and coordinate axis? Well, again, using a similar concept, 2a plus 2b plus c is 0 corresponds to the fact that ax plus by plus c always passes through the fixed point 2, 2. And we need 2 lines which also additionally, in addition to this constraint, also satisfy the constraint of being at unit distance from the point 1, 1. Well, we know that 1, 1 is a distance of square root of 2 from 2, 2. So we want 45 degrees away, right? So quite simply by observation, we can deduce that the lines y is equal to 2 and x is equal to 2 satisfy the distance of being unit distance away from 1, 1. So the area bounded by L1, L2 and the coordinate axis is simply 4. 2 times 2.